Good morning everyone. Welcome back to your physics class. Today we are going to start our next chapter, a new chapter, that is calorimetry. This is a portion of heat and today we are going to start this one. Okay. So before we start this calorimetry, or we learn what is calorimetry, or we learn what is calorimeter, first we will understand what is heat, how can we measure heat, what is temperature and all. So we are going to discuss this. And to start the chapter and to start what is heat, there are some terms which we are going to discuss first. We are going to talk about the kinetic energy of a molecule. We are going to talk about the potential energy of a molecule, and then we are going to talk about the heat or the energies what the molecules possess. Okay. Now let us talk about how what is the molecular structure and how it works. Okay, we know that the molecules, whatever molecules, whether they are the molecules of solids, liquid or gases, we know that the molecules, they vibrate. In solids they vibrate at their own position, in liquid they do vibrate, and then in gases as well they have this random motion. So that means the molecules, since because they are vibrating, they are oscillating, then they must be having some sort of kinetic energy. So that means molecules will have kinetic energy. Molecules means whatever molecules they are, solids, liquid or gases. And then we have potential energy. We know that all the molecules, they are having a force of attraction with each other, like they attract, they do have some forces of attraction with each other, and because of that, because of their position, because of their configuration, we have, or they possess this potential energy. That means the molecules possess kinetic energy because of their vibrations. Molecules possess potential energy because of the force of attraction and the position, they attract each other and all the close binding, they possess potential energy, which means that the molecules of a body possess both kinetic energy as well as potential energy, and the sum of kinetic energy and potential energy is known as their total internal energy. Internal energy. Since we are talking on a microscopic level, we are talking about molecules, and since we are talking about the energies possessed by the molecules, that is, they possess both kinetic energy and potential energy, and that's why the total sum is total. And we are talking about the on a microscopic level, so it is internal energy, total internal energy. Okay, so that means in a body, all the molecules present in a body will have the total internal energy, correct? So now if we are talking about a body, let's take a body, it is made up of molecules, so all the molecules will have total internal energy, and the sum of all energy will be the total internal energy of the body. Is it correct? Is it okay? And now if we talk about a body, two different type of bodies. Let's say we are talking about a hot body, that means which is having a high temperature, and we are talking about a cold body which is having a low temperature. I hope you understand, when we increase the temperature, we have learned this in class 9th, that whenever we increase the temperature, if we are talking about a molecule, when we increase the temperature, that means we are providing some energy, heat, that means the motion of the molecules or the vibration of the molecules will increase. That means its kinetic energy will increase, or the total internal energy will increase, and that's how we can say, in comparison of this hot body and cold body, we can say that in comparison of this, we will get to know that the hot body will have more total internal energy in comparison of this cold body, because in cold body the vibrations will be not as much as the hot body. That means this is for a body which is at higher temperature, the total internal energy will be more, and for a body at lower temperature, the total internal energy will be less. Okay, now what will happen if these two type of bodies will come in contact? Like if we are having a hot body, we are having a cold body, or you can say that this body is having a different total internal energy, this will have something else because it will be more total internal energy, and this body will have a less total internal energy. And when the bodies will come in contact, what will happen? Of course, the energy will transfer from the higher concentration or the hot body to the cold body, isn't it? The energy will start transferring from hot body to cold body. Okay, now see the amount. Let's say that this body is at 80 degrees Celsius, okay, and this body is at 60 degrees Celsius. I am just writing the temperature so that you can understand that one is hot and one is cold, meaning that this one will have more total internal energy and this will have less total internal energy. And when they come in contact, when we put them together, the energy will flow from hot body to the cold body. And when energy, let's say some amount of energy is flowing, okay, and let's say 10 joule energy flows from the hot body to the cold body, the energy which is transferring to make them at equal level, the amount of energy or the energy which is transferring is known as heat. That means there are two bodies or different bodies can have different total internal energy depending upon their kinetic energy and potential energy, because kinetic energy plus potential energy gives you total internal energy. That means two bodies can have different total internal energy. When we bring them closer, when we bring them together, the energy will transfer from one body to the other body, and the amount of energy which is transferring from one body to the other body will be known as heat. That means the bodies don't possess heat. Heat is, if you read a little, if you read good books, and you will find, not good books, but you will find it in every book, that heat is actually energy. Which energy? Total internal energy. But then heat is the energy in transit. It's not like that this body will have some different heat or this heat, because this body will have total internal energy. This body will have total internal energy, and the energy which is transferring from one body to the other body is known as the heat, or is known as heat. That means heat is the energy which is in transit, which transfers. If it is like, let's say that this hot body is having amount of total internal energy, let's say 100 joule, and this body is having the energy, let's say 80 joule, okay, let's say 80 joule. So of course this is having more internal energy, this is having less internal energy, and what amount of energy is transferring? 10 joule. So that it will become 90 joule and it will become 90 joule. So they are now equal. So which amount of energy is transferring? 10 joule. So heat will be 10 joule, because heat by definition is the energy in transit. I hope you all are understanding that what is heat. We have this total internal energy, and then the energy transfer from one body to the other body is known as the heat. Heat is the energy in transit. Heat is the energy which we talk about, is actually the energy which transfers. It's not that it is possessed by a body. Yes, energy possessed by a body, but then the amount of energy which is transferring to the other body, that transfer amount is known as the heat. Okay. Now second thing, if we can measure heat, that means we are measuring heat. This was at 100 joule, this was having 80 joule, and now 10 joule is transferring from one body to the other body. That means we can measure heat. So how can we measure heat? That means there must be some apparatus or something that by which we can measure this heat. Yes, that apparatus or that thing is known as calorimeter, and the process of measuring the heat is known as calorimetry. Okay, now let us talk about the units of heat. As we know that heat can be measured by the apparatus known as calorimeter, and the measurement of heat, this is known as calorimetry. Now heat is having a very common unit, or most common unit, or SI unit of this heat is joule. We know, just now I have written there that we can measure heat in joule. Also the other common unit is calorie. Okay, So we can measure heat. I hope you all know that we can measure heat 10 joule, 20 joule, 30 joule, or we can measure heat in calorie as well. And the relation of 1 calorie and joule is 1 calorie equals to 4.186 joule, or simply we write 4.2 joule. This is the relation between the calorie and this joule. Okay, this is the relation. Now after this heat and the idea of this heat, by the way, when we proceed further, I want you to remember one thing, that how are we describing the total internal energy. Total internal energy means there are molecules present in a body. All molecules will have their kinetic energy and potential energy, all of them, and the total sum of the kinetic energy and potential energy will be the total internal energy. This is the, and the amount of total internal energy transfers from one body to the other body is known as the heat. Clear? Now let us go move on our further next topic, that is temperature. Okay, now if we are talking about temperature, what definition or what thing comes in your mind first? If we talk about temperature, see, very common thing you have all learned, that temperature, as we have learned in junior classes, that temperature is the degree of hotness and coldness. Yes, it is correct that temperature determines, or it is a degree, or it tells you the degree of hotness of a body and coldness of a body. But here we are going to see what is temperature and how can we understand temperature in a different way, or what is actually temperature. Okay, now you see, if you want to, if I ask you that if I give you two bodies, okay, and if I ask you that can you tell me that heat will flow from which body to which body, so the one common thing is that you can ask me, if I am giving you this body and this body, okay, and if I ask you that here we are having two bodies and you tell me that the heat will flow from which body to which body, so there is one way. You can simply ask me what is the temperature. Now if I ask you, if I tell you that this body is at 40 degrees Celsius and this body is at 10 degrees Celsius, so heat flows from body A to body B or body B to body A. Of course you would tell me that the heat will flow from body A to body B. Why? Because there is a temperature difference. It is at 40 higher temperature to lower temperature. That means, how are you telling me, or how are you able to tell that heat flows from which body to which body? This is temperature. That means temperature is a parameter which decides the direction of flow of heat. Temperature is a parameter, isn't it? Because by knowing temperature you can decide that what will be the direction of flow of heat. Is a parameter to, now you can write which decides the direction of flow of heat, isn't it? I am hoping that you all are able to relate. If you are having two bodies, just see the temperature, which one will be at high temperature, that means heat will flow from high temperature to low temperature. That means it is a parameter which decides the direction, or which will tell you the direction of flow of heat. This is the first definition. Second definition, you can see that in terms of total internal energy, we know that all the molecules will have kinetic energy and potential energy, and the sum of all kinetic energy and potential energy is known as the total internal energy. Now if I write this term total internal energy, I hope that you all are able to relate total internal energy. But if I tell you what is average internal energy, these two terms are different. This one, the first one is total internal energy, second one is average internal energy. So if we talk about temperature is heat is the total internal energy which transits from one body to the other body. But if we talk about temperature, temperature is average internal energy. And let me tell you, average means if we are having if we want to calculate average, average means sum of observations upon number of observations. You always divide it by number of observations. But total means simply the sum of all. So I hope you can understand the difference between the two. And now if we talk about the definition of temperature, temperature can be calculated of a body, or the temperature of a body can be calculated by calculating the average internal energy. That means if you are calculating the average, there are 10 molecules and you want to calculate average internal energy, sum them all and divide it by 10. That's how we calculate average. I hope you all are getting it. Average internal energy. So whenever you calculate average internal energy, that will give you the temperature of a body. If you calculate total, the sum of all, that will give you the total internal energy. So there are three definitions we have learned about the temperature. The first one, which we have learned in our junior classes, that is, it is the degree of hotness and coldness. Second, it is a parameter which decides the direction of flow of heat. Or third is that the temperature is actually the average internal energy. Now, I have a question for you all. See, we will be learning the unit and this thing all, the unit of temperature. But before that, I have this thing, that in your book there is a chart given in which they have written the difference between temperature and heat, which is now you have learned that you can write temperature is the average internal energy, whereas this heat is the total internal energy, and all difference you can write. I am asking you a question. Let's say that there is a river and the river is at let's say all the water in the river is at 40 degrees Celsius. Okay, the water in the river is at 40 degrees Celsius. What will happen, or if we take out a glass of water from the river, this is the river, and if we take out a glass of water from the river, this will also be at 40 degrees Celsius. Now I am asking you that for these two, which will be same, like both the river and this glass of water will have same heat, same amount of heat, or they will have same temperature? You let me know, or you decide, or even if you get the answer which I have written already, if you get the answer, do let me know. Okay. And second thing, now let's talk about the units of the temperature, or temperature can be measured in which units. So common units, you know, the SI unit we know it is Kelvin. Let's talk about the units of temperature. The SI unit of temperature is Kelvin. The other commonly known units or used unit is Celsius, which we always use, and also is Fahrenheit. So, and also we know that which apparatus we use to measure temperature, a very common one, that is the thermometer. Okay. So here I am going to talk about the three scales of this to measure temperature. We know that there is a Celsius scale, that means we can measure temperature in Celsius. So you can write that this is a Celsius scale. Also we know that we can measure temperature in Fahrenheit, degree Celsius and degree Fahrenheit. That means there can be a thermometer in Celsius scale, there can be a thermometer in this Fahrenheit scale, and then there can be a thermometer in Kelvin scale. Understand? Understood? Okay. Now here, if we talk about the Celsius scale, generally the thermometer has this ice point. This ice point you can say, or the lowest point is 0 degree Celsius, at which the height this ice will form, and then we have this maximum point is 100 degree Celsius, the ice point and the boiling point, the same. And by the way, this thermometer will have this 100 divisions, and that's how it is starting from 0 degree Celsius and ending at the boiling point is at 100 degree Celsius. Now if we talk about the Fahrenheit scale, the ice point is at 32 degree Fahrenheit. Okay, that means if you are measuring temperature and the ice is being formed, that means if you are taking a Fahrenheit thermometer, it will give you a reading of 32 degree Fahrenheit, whereas if you measure the temperature with Celsius scale, it will give you 0 degree Celsius. And the this point is 212 degree Fahrenheit. That means this is the boiling point, and this thermometer will have 180 division. You can see from 32 to 212 there are 180 divisions. These two scales we have. Now let us come to this Kelvin scale. The ice point will be at 273. What we have learned in our junior classes that it is 273 to 373, but it is not actually 273 but 273.15 Kelvin, and the highest point is 373.15 Kelvin. And since it is from 273 to 373, it will also have 100 divisions. Okay, so that means if you see 0 degree Celsius is equal to 32 degree Fahrenheit is equal to 273.15 Kelvin. These are three scales which we commonly use: Celsius, Fahrenheit and Kelvin. By the way, this Kelvin scale can go down further and it can measure our lowest temperature of 0 Kelvin. That means this scale can measure a temperature of 0 Kelvin. Below this it can measure temperature and it can go up to measuring 0 Kelvin. 0 Kelvin is known as the absolute temperature, and this 0, it is not okay written, it is 0 Kelvin and it is known as the absolute temperature. It is a temperature at which the vibration of the molecules ceases. Okay, we know that the molecules vibrate every time they vibrate, like whether they are molecules of solid, liquid and gases, they vibrate. But what we consider is that if we measure the temperature and if a substance has this temperature at 0 Kelvin, the vibration of the molecule will cease. That means it will stop, which is of course not in a real condition. You cannot measure 0 Kelvin. No, it will not, it cannot happen. But then we say that this is the absolute temperature. Okay, below this you cannot measure temperature because a Kelvin scale is not in negative. Like we can measure in the degree Celsius, we can measure minus 53 degrees Celsius, we can measure minus 14 degrees Celsius, but in this is the minimum temperature in this Kelvin scale. You cannot measure any temperature below this, and of course because this is the temperature when the vibration of the molecule ceases, so you cannot go below this. Okay, now let's see the relation between all. Okay, now see the relation. Relation means that how can we convert one temperature into the other. If we are given with 40 degrees Celsius, how can we convert degree Celsius into Fahrenheit or to Kelvin? So let's say any temperature here we are taking is T degrees Celsius. So the relation here is T degrees Celsius, the temperature 10 degree, 40 degree or whatever, minus the ice point, that is 0 degrees Celsius, divided by the number of divisions, that is 100, equals what is, let's say here is it is T degree Fahrenheit minus the ice point which is 32 upon the division, number of division, this is 180, equals we have this temperature. Let's say here also it is T, but then if you know that since Kelvin is the SI unit and Kelvin, whenever we measure temperature we denote it by capital T. So the temperature which we are measuring in Kelvin, let's say capital T, minus what is the ice point, is it is 273.15 and divided by the number of division which is 100. This is the relation between all three temperatures. I hope it is clear. Now let's see what we have learned and let's see how it is connecting to that. Now if we take 2 and we simplify, let's take this 2. Now if we want to change one temperature into the other, let's say we want to change this Celsius into this Kelvin, so that means we will take this one and this one together. That means we take T degree Celsius minus 0 degree Celsius, or you just write 0 divided by 100 equals this, that is T minus 273.15 divided by 100. Clear? Now this 100 and this 100 will be cancelled, and we have this T degree Celsius minus 0 means it is simply T degree Celsius equals T minus 273.15, or this can come to this side, or you will get T equals T degree Celsius plus 273.15. That means if you want to change any temperature like 30 degrees Celsius or 40 degrees Celsius, you want to change this into Kelvin temperature, you just have to add 273.15 and you will get this temperature in Kelvin. That's what we have learned, that if we want to change this 35 degrees Celsius into Kelvin, we have to add 273. We have learned that we have to add 273 and then the temperature will be in Kelvin, and that's how we have we are getting. So here you see that these are the three relations. This is the relation between all these three scales you can use. If you want to change the temperature from degree Celsius to Fahrenheit, you can take these two and you can handle these two. I will show you that how what will you get. Hope you have learned it too. You see, here we have T degree Celsius minus 0 degree Celsius. I am not writing because now we have this T degree Fahrenheit, that means temperature in degree Celsius, temperature in Fahrenheit minus 32 over 180. This 0 0 cancel. We have this 5 and then we have this 9. Correct? Now this 9 will come to this side, so it is 9 times T degree Celsius, and this will go to this side 5 times temperature in Fahrenheit minus 32, or temperature in degree Celsius will be 5 over 9 temperature in Fahrenheit minus 3. This is the formula to convert either temperature in degree Celsius to Fahrenheit or Fahrenheit to degree Celsius. This formula you also have learned in junior classes. So that's how you can use any two at a time, and then you can convert one temperature into the other. Okay. As we have seen these scales, the Celsius scale, Fahrenheit and Kelvin, you see the Celsius scale and Kelvin scale, they are quite having something same. Like the Celsius scale is having 100 divisions. Kelvin scale also has this 100 divisions. That means if you are changing 1 degree here, you will change 1 degree there also, no? So that means if you can see, if you're talking about change in temperature in degree Celsius, it will be same as change in temperature in Kelvin. So you see, if you are changing temperature, this is the temperature in degree Celsius, this is the temperature in Kelvin, and they will be same. This is a very important thing and you need to keep this in your mind. This is already written in your book. Just mark it so that when you simplify numericals, you will keep this in your mind. That now we have factors affecting the quantity of heat absorbed to change the temperature. Now if we are heating a body, of course it will absorb some heat and the temperature will change, the temperature will rise, and so that the body's temperature will change. So what are the factors? Okay, so we'll take an example. If we take a cup of water in a cup, and if we take water in a bucket, the material is same. We are taking water in a cup and in a bucket. If I ask you, if I am giving heat to cup and to if I am heating the cup and the bucket, which one will have the temperature raised first? Or if I want to raise the temperature of the cup and the bucket both, which will take more heat? Of course the bucket will take more heat. Why? Because more will be the mass, or more will be the amount, more heat will get absorbed, or more heat it is required to change the temperature. Clear or not? That means the heat, let's say the heat we are denoting by Q, the amount of heat absorbed by the body, which body, bucket or cup, the amount of heat absorbed depends, or it is directly proportional to the mass of the substance. That means in bucket we have more water, so if more water, more heat will be absorbed. If we have less water in cup, less heat will be absorbed. More mass, more heat absorbed. Less mass, less heat will absorb. So The change in heat will depend on this first factor. Second factor, now if we are having, now we are having both the cups, we are having same quantity of water, we are having two cups, one cup, second cup, same amount of water, that means mass is now same. Now if I want to raise the temperature of first cup by 1 degree Celsius only and the other cup by 2 degrees Celsius, so in which cup I have to give more energy or more heat? Of course the second cup, because here I want to change temperature more. I want to change it by 2 degrees Celsius and here I want to change it by 1 degree Celsius. That means if I want to change more temperature, I have to give more heat. That means the amount of heat is directly proportional to the change in temperature. Correct? More change in temperature, more heat required or more heat will get absorbed. Is it clear? I hope it is clear. Now if I combine these two ideas, that means Q depends on this, or Q is directly proportional to M and Q is directly proportional to delta T. If I write it together, Q is directly proportional to M and this delta T, so into delta T. Is it okay? That means the amount of heat absorbed depends on the mass of the body. More mass, more heat. It also depends, or it also is directly proportional to change in temperature. We want more change in temperature, we have to give more heat. Clear? Now as we have learned, whenever we have to remove the proportionality sign, we have to apply a constant, that is known as the constant, proportionality constant or constant of proportionality. So here I am removing this proportional sign with the equal sign and I am using a constant. Here the constant is small c and we have this m as it is delta t. So if I write it properly, it is m c delta t, where c, small c, is the constant and here the name of the constant is specific heat. This constant, the name of this constant is specific heat. It is different for different materials, like for water specific heat capacity is different, for ice specific heat capacity is different, for mercury it is different. So for different material it is different. That means heat absorbed by a body depends on three factors. It depends on the mass of the body or substance, it depends on the specific heat capacity, and also it depends the change in temperature. Okay. Now if I ask you to keep this here and then these two, bring this to that side, that means small c. This is small c. Specific heat capacity is denoted by small c, which is equal to Q upon M into delta T. Now by the unit of this specific heat, it will be, what is the unit of this heat? That is joule, the SI unit, divided means this per. Mass will be in kilogram and temperature will be in Kelvin. Now if I write it properly, joule, this kilogram is in divide, if it goes to the numerator it will be kilogram inverse and then this Kelvin inverse. Okay. Specific heat capacity, if you see the definition of specific heat capacity, it is the amount of, you see C depends on Q, it is the amount of heat required to change the temperature of a unit mass of a body by 1 degree Celsius. You please see the definition, and we will be discussing the definition of specific heat capacity and heat capacity, and we will see the difference in our next class. Till then I am expecting that you are gonna go and read your chapter, see what is heat, what is temperature and what is specific heat capacity, and we will continue it in our next class.